Okay, Year 11, this part of the topic is all about upthrust. Now, you've heard of upthrust before. You should know that upthrust is one of the many types of force that we see in the physical world. You should know that upthrust is also the force that keeps things afloat. Okay, right? It's the force that keeps things afloat, but it's also a force that's exerted on objects that sink. Okay. Now let me show you upthrust in action. Right, I've got a glass block. Now, if we were to measure what forces are acting on the glass block at the moment? Okay, you should be saying, right, there's the weight of the glass block pulling down, and there's tension in the string pulling up. Now, those two forces are balanced. The tension upwards is equal to the weight pulling down. Now, if we can measure the value, okay, the value of the weight of that block with a Newton meter, you should be able to see that the weight, the force pulling down on that block is 1.0 newtons. Okay, that's the weight on the block. Right, if we were to fully submerge it in water, we should see now that the weight appears to be 0.6 newtons. Now, what's the reason for that? Why is it that the weight in air is 1.0 newtons, but the weight when it's fully submerged in water is 0.6 newtons? The reason is because there's an extra force now acting on the glass block. There's now upthrust trying to push the glass block upwards. Okay, but how much force is now pushing the glass block upwards? Well, if in air, if the true weight of the glass block is 1.0 and the reading now is 0.6, then the upthrust pushing up on the glass block, that's the upthrust, the float force from the water trying to push it up, is, anyone get it? 0.4 newtons. Because we've got 1 newton pulling down in air. Okay, now the resultant, the net force pulling down is only 0.6 because there's an extra force of 0.4 pushing it up. Okay, so that's upthrust, and that is what, and that is how you measure the upthrust of an object. Okay, now if I was to let go of this, okay, if I was to let go of that, it's going to sink. Now, why is it going to sink to the bottom? Well, if the upthrust on the glass block is 0.4 and the weight is 1.0, the upthrust is not high enough to balance out the weight. It's not high enough to go in the opposite direction and cancel out the weight of the block, so it sinks to the bottom. If we have something that is less dense, so therefore has a smaller mass and therefore a smaller weight for its size, it's more likely to float, okay? Because when things float in water, the water that they actually displace to cause an upthrust is actually enough to balance out the weight of the thing going down, because the weight of that is actually quite small, certainly compared to the glass block. And there we have it. That's why things float. Because the upthrust on these is high enough to cancel out the weight of the object pulling down. However, if the weight of the object is high, because we have a material that has a high density, then it doesn't matter